my name is Ben Cohen, and we brought a project called Gogh Bike or Bike Go. It's a collaborative biking painting interface that lets people mix paint made out of light and project a painting on a digital canvas.
Oh, that's amazing. And who are my two other people over there?
And so the other people on this project are Greenberg and Joyce Tsai.
Okay. And so tell me a little bit about what I'm seeing right now. Tell me tell me all the pieces that you guys are working.
Sure. So we've got basically two main components to the bike. There's somebody who rides the bike and controls the paintbrush.
Okay.
And they can control the speed and direction of the brush based on the speed they pedal and the direction they move the handlebars.
Okay.
And then on the back of the bike, there is a paint bucket, and there are these four colored buckets of paint, which are actually buckets of light that can be poured into the bucket on the back. And so we wanted to provide a little bit of feedback in the project. So on the paint can, there's an array of LEDs that displays the color and amount of paint in the bucket.
Okay.
And we also have a sound effect for when the bucket detects pouring of paint, and it's that glug, glug, glug sound that you might hear if you were really pouring paint.
Yeah, that's wonderful. That's really appealing. That's amazing. Okay, and so tell me a little bit about, so these are pretty simple buckets with a light in them, and tell me how you hook it all together.
Sure. So we're actually using the Arduino reprogrammable microcontrollers, and we've got three of those. One of them detects the movement from the bicycle. One of them detects the light being poured into the bucket, and that happens with three color sensors that have the same color gels as the light buckets.
Oh, okay.
And to detect the color, we detect the relative light levels on each sensor.
Okay.
And then the last Arduino controls the actual display of the light level in the paint bucket.
Oh, okay, wonderful. And in terms of, you guys were talking about this is the first time you guys have had a lot of kids on here.
Yes,
so.
we designed this for a graduate class project at UC Berkeley, and our target user was sort of an adult with an understanding of the sensitivity of all the electronics, and then we brought it to Maker Faire, and almost all of our users have been fairly young children who are really enthusiastic painters and users of the bike, but sometimes they use it very rigorously.
Yes. So how many times have you had to rebuild?
So yesterday we had our worst break where the steering actually came unsecured.
Oh, excellent.
So we were down for the whole afternoon, and today we've just rewired it a half dozen times.
Oh, okay, excellent.
I was responsible for writing some of the light detection code and the processing sketch that kind of ties all the pieces together.
Okay, so processing sketch that ties all the pieces together. So tell me a few of the adventures that you had as you were working on the project, because it's not a straight line.
Yeah.
Right?
So one of the things that was really interesting and challenging is that almost all computers deal with light as red, green, and blue. But red, green, blue is not a very intuitive way for people to mix colors. A lot of artists are more familiar with red, yellow, and blue.
Yeah.
But that's not the way a lot of normal computer paint works, so we had to get some code from the University of Minnesota. A couple computer scientists there figured out a good way to translate between red, yellow, blue, and red, green, blue. And so that's part of the processing sketch that we put together. So we used a variation of C or wiring that we used on the Arduino boards. There are three different Arduinos connected in this project. Each of them is running a relatively simple sketch. And those are all communicating with one processing sketch, and processing is kind of a variant of Java. And so that's what manages, for example, the bike and the canvas and then the paint can. One of the things that was a little tricky is we wanted people to be able to mix the colors of paint. So in the paint can, when you put in red, it adds 10 units of red to whatever paint is currently in there. So if it's a blue, it'll make a purple, but depending on how much blue is in there, it will make a darker blue, a darker purple, a lighter purple.
Oh, that's great. And there is white in the system too, right?
Right. So
how does that work?
Well, the thing about red, yellow, blue is that when you mix those three colors, there's a lot of colors that you can't get because you're always making it darker. So if you mix red, yellow, and blue in equal parts, you usually get just kind of a funky looking brown. So we added in white so that people could kind of lighten up whatever color they currently have. That way they can get pinks, they can get light blues, they can get light yellows, light greens. So we use red, yellow, blue, and then white for people to kind of have a little bit more flexibility. Light detection code was particularly difficult. The sensor that we wanted to use, SparkFun sells a very handy color light sensor, but that was sold out when we were building this project. So it's an array of just standard photo sensors that detect not color light, but just amount of light. We put them under different colored films. So the photo sensor under the yellow film should detect more light relative to the others when you put the red bucket over it, and so on and so forth. So what we do is we have this calibration routine. We read all of the buckets one by one, and we store that in what's called EEPROM on the Arduino board. And then we run a system that is always comparing the current values to see if it is roughly similar to a previous value during the calibration. The thing is that the calibration code is not, the sensing code is not very good. So what we tell people to do is we tell them to shake the bucket over the sensor, and that way, while they're shaking it, eventually they'll get to the point where it matches the initial red value. So it's a bit of a hack to make it work, but it seems to work relatively well because people are used to the idea of kind of shaking paint out of a can.
To get more. That's beautiful. Yeah. That's great. That's a great usability win.
A lot of the sensors that we use are not very complex sensors. They're familiar to a lot of hobbyists. Magnetic reed sensor, and also a potentiometer. And the real challenge was really getting them attached to the bicycle in ways that were going to be durable. We initially used a combination of silly putty, Gorilla Tape, inflatable foam, and so that was probably the most difficult task there. Joyce, who was kind of our hardware guru on the project.
I am the hardware person, although actually that means tape, Gorilla Tape, glue, more tape, glue, more tape.
Yeah. Bubble gum.
Yeah. No, actually we didn't use bubble gum, though we did have silly putty for a while.
Okay, awesome.
Yeah, it was a good test.
So tell me about some of the challenges from your perspective. I mean, other than needing to rebuild.
Yeah, that's the big one. So most of the wiring on the bike is okay, but we made the mistake of, as you probably saw over there, having everything on the solderless breadboards.
Yeah.
So every so often, one of the kids kicks the wires and everything pops out, and you have to rewire everything, and then you wire something wrong, and etc.
Well, you did it as a school project, and so yeah. So what did you learn so that you would do it differently as you hit the real world? So that would be a great question.
Yeah. So basically, for the school project, everything was on the breadboards, including that entire LED array in the bucket. So there are like, I think, 12 LEDs in there, all wired up to one Arduino. When we displayed it for school, that was all hooked onto a breadboard, which was stuffed in the paint can. And basically, anytime the paint can moved, one of the wires would come out, and you'd have to like kind of wiggle your hand inside to try to rewire like 12 LEDs.
Oh, exciting!
Yeah, it was very exciting. We did it once or twice, and I think like the whole bucket came apart. Yeah. So this time around, we got one of the perf boards and soldered the LED array to that, but we didn't either. I don't know why we didn't solder everything else. We really should have.
That's okay. It sounds like you learned a lot about putting limits.
Yeah.
So now you have bumpers on everything.
Yeah. And Ryan is the guy who comes up with these great like engineering ideas. Like he came up with the idea for the board on the wheel, and we would somehow wire the pot to it and put it on the platform, and it would turn. And then we were like, no, actually, the Gorilla Tape and chopsticks work better. Yeah.
I like it.
Yeah.
Thank you.
No problem.